Kia ora, Year 12. This is the last question from yesterday's test, and this is a differential equation question where we have to set it up and then solve it and then solve a problem using our particular solution. So we're given that the population of a country at time t years is n millions, and n is assumed to increase at a rate proportional to the product of n and 1 minus 0.01 of n. When t is 0, the population is 20 million, and dn by dt is 0.32. Okay, so the first thing you have to do, and it's actually a bit of mucking around for 1 mark, is you have to show that they satisfy this differential equation. So to do that, I want you to actually set the DE up from the start and work through to here. That's what the marking schedule needed. So I don't just want you to substitute in this and this. I had some of you did this equals this on 2 sides. So we're basically going from the start and getting it done. Right, okay, next we have to solve the DE, solving this. So we'll be using separating the variables in there. And then we have to get an expression for t in terms of n, right? Not n in terms of t. So we want to make t the subject, so t equals blah, blah, blah. And then we have to figure out when the population will be double its value at t equals 0. In other words, we have to find out when is n equal to 40. Okay, so starting off, we're told that n increases at a rate proportional. So that means that dn by dt is proportional to n times 1 minus that. So we can write that as dn by dt is equal to kn times 1 minus 0.01 n. Substituting in now gives me 0.32 is equal to k times 20 times 1 minus, so 0.01 of n is 0.2. So all up, what does that give me? Well, I get over here, this is 16. So k is equal to 0.32 over 16, which is 0.02. So dn by dt is equal to what we were given. Okay, so that's that. Now, I know that's quite a bit for 1 mark, but I think that is a really good question in how we go from the start, from the word problem to setting up the DE, right? Because you'll quite often be asked in both NCEA and in Cambridge to go from a fact setup and then set up the DE and solve it. Next thing we've got to do is we've got to solve that differential equation. So this is 8 marks, so you should be expecting that it is going to be a bit of work, and you need to be confident with your partial fractions for this question. This is slightly harder than NCEA level 3 DEs, but not bad if you know partial fractions. So we'll start with this, and we're looking in there for anything that's got a t in it and all the stuff that's got n's in it. So this is my n stuff. This is going to come over to this side. I'm going to leave this here. That gives me 1 over n. I don't know why it's doing that. So 1 over n times 1 over 1 minus 0.01 n is equal to dn is equal to 0.02 dt. And I'm going to integrate both sides, right? So that's the usual setup. But this is a big mess to integrate. So we need to split that up into a sum. 1 over n times 1 minus 0.01 n can be broken up into a over n plus b over 1 minus 0.01 n. 1 is equal to a times this. So this is all that stuff you did at the start of the year on partial fractions. And now I'm going to substitute in n equals 0. So when n equals 0, we get 1 is equal to a times 1 plus 0. So that means that a is equal to 1. Now substituting in here, I'm going to substitute in n equals 100. And I get 1 is equal to a times 0 plus b times 100. So b is equal to 0.01, right? So 1 is equal to 100b. That means that I can now rewrite that integral into something nice. So we'll call this star. We get a over n, so 1 over n plus 0.01 over 1 minus that. And on this side, I'm going to do my integration now, and I get 0.02t plus c. On the left-hand side, we'll have the natural log of n. Now here I've got the nice pattern that the derivative of this is almost the top line. So it's going to be minus the natural log of 1 minus 0.01 n is equal to 0.02t plus c. So rewriting this, I get the natural log of n over 1 minus 0.01 n is equal to that. Now, usually here I would do e to both sides, and I've actually done that in my work solutions because we're so used to that, but I'm asked here to make t the subject, right? So that's not too bad. We're going to just rearrange stuff from this side, and we'll get the natural log of n over 1 minus 0.01 n minus c. And this 0.02 we can think of as 1/50th, right? So that's going to help. So now I just left with this. So 50 times that is equal to t. And we're done. Right, that's 8 marks. Let's just have a look and see. No, we're not done. We're not at all done. We haven't figured out what the constant is. Forget that, guys. So I could have substituted my constant in at any point, actually. I could have chucked it in here, but I'm just going to do it down here. What do we know? Well, we know that we've got at t equals 0, n is equal to 20. So substituting in, I get 50 ln of 20 over 1 minus 0.2, right? Substituting 20 in here. 20 times 0.01 is 0.2 minus c. Sorry, brain is going very slowly, guys. Let's just fix this up. What am I doing? Yeah, I don't know what's wrong with me. I'm not going to start the video again, guys, sorry. But look, the first thing I can do here is that I've got 50 times all of this is equal to 0. So I can just divide both sides by 50. Okay, so c is equal to the natural log of 20 over 0.8, which is the natural log of 25. And we're going to go back and clean this up a bit better now. We've got 50 times the natural log of n over this. And I can again simplify using my level 2 log rules. So 50 times the natural log of n over 25, 1 minus 0.01 n is equal to t. That's fine, but I'm going to make it look even nicer. We're going to get n over 25 minus 0.25 n is equal to t. Pretty sure you get 4 marks for getting to there. I'm going to show you how to get what came through in the schedule, just in case you're not quite sure. One thing that doesn't look so nice in here is having that decimal in there. Right? Well, you probably don't mind because you guys all like decimals more than me. But this is equal to 1/4. So I'm going to times the top and bottom here through by 4. And that will give me 4n over 100 minus n equals t. Okay, but I'm sure that if you had that, that would be fine. That is probably also fine, but that looks really ugly to me, right? So this looks really nice. So the last thing we've got to do is to figure out when is n 40. So t is equal to 50 times the natural log of 160 over 100 minus 640, which is 60, which is 49.04. So it takes 49 years, so approximately, for the population to double. So there you go, a pretty kind of nitpicky, fiddly question in some ways, but also really, really good to get confident with the partial fraction split up in a DE, because that does sometimes pop up. And you can see that it pops up in real life kind of problems. Okay, thanks for watching. If you've got any questions about any of that, just send me an email and I can write back.